where do you place the mount target to do that? Great. I should have checked that before the end of the period, but that's fine. Going back to autoscaling can be as easy as 1, 2, 3, 4. We have 4 steps. First step that we need to create an instance configuration. Instance configuration, we did one yesterday. Let me check if I added everything that I needed. Create the instance, block volumes to attach, and I can't see if I added the cloud init. So I'll create another one, and it's good to review. I'll call it my LB config, because we will use this with our load balancer. Where is my cloud init configuration? My agenda. I have it here. Okay. So when you create the instance configuration, it's pretty much the same information that you have when you provision an instance. But in this case, it will not provision anything. It will just save the metadata. So you do the placement, the type of capacity that you want to use, if you want to specify some fault domain, the type of what image you're going to use, what type of shape you're going to use, where are you going to place the instances, if you're going to assign IPs or not. As we are going to put behind the load balancer, I don't need to assign a public IP. We won't get another secret list, but we still want to be able to access. Let me just upload my public key here. Those are all the options that I need. And where is the cloud init? Boot volume. Okay, we are going here on the cloud init because I want to have a few extra packets installed. And I will create my instance configuration. Second step after having a instance configuration is to have a pool. What is the instance pool? The instance pool is a group of computers that you manage together, how they behave. So how the pool behave. You can add more. Just a second, let me mute here. Someone is making some noise. Okay. When you have a pool, you control the number of instances that are on the pool, how they spread through availability domains, and you control the number of instances. You can have a pool from 0 to all your limit of instances, and you can control that pool with an auto-scaling policy. So second step is having a pool. You can create the pool from within the configuration details, or if you are on the first level here, you can click on instance pool, create an instance pool, and then you can pick the configuration that you want. Or if you are on the instance configuration, you just click here on the button, create instance configuration. It already has something filled for you. The number of starting instances, as we are going to attach this to a load balancer or to an auto-scaling policy, we can have this set to 0. you will review the information that you added on the configuration. You can't change it here, but you can review what you have just to make sure that you are on the right track. Next, you're going to choose where the instances will be placed. If you have a region that has more than one availability domain, you can specify all the 3 availability domains that you have here. If you are going to put it with a load balancer, you can come here and select a load balancer. I thought I had created, but we can, okay, let me uncheck this. And we'll make a pause on the step 2 of our autoscaling, because I will make a parenthesis so we can talk about load balancers. Load balancers, they are meant to, it's a resource that we use to distribute network load across a backend set that we have. On OCI, we have 2 types of load balancers. We have the network load balancer. It's a low latency load balancer, and it works on layer 3 and 4. So it just redirects IP traffic and TCP or UDP traffic. Biggest advantage of this network load balancer compared to the other load balancer is it much faster, and you don't pay for it. It's free. On the free account, there's I don't remember the number of instances that you can have, but we don't charge for the network load balancers. Comparing, for example, with AWS, they have a network load balancer and you have to pay for it. Comparing against the load balancer that we have here, the difference is this one works layer 4, layer 3. The load balancer, they work on, it has some features on layer 4, but it's intended to work on the layer 7, where it will shine, it will be able to set cookies, it's able to do persistence on different ways that this guy here, as it's working on lower network layers, will not be able to do. As we're going to demonstrate with a web server, I will create this load balancer here. Srini, layer 4, layer 7, they are the Aussie layers. Cornelius, it could be some bandwidth problems with Zoom. On my end here, this is a live screen. It's not I don't have control, so it could be something on the network. So Srini, layers 4, layer 7, they are the Aussie model. You're gonna, unfortunately, I won't have a chance to go through the Aussie model here, but it's you will have to make some research on that.
So
layer 4.
How do you spell it? Aussie model. Sorry, Orlando.
No, not a problem. Let me get here. So if you just Google for Aussie model, on chat.
Fine. OSI, right? Okay, got it.
OSI.
Open source. Yeah, yeah, I got it. Thanks.
Open standards. Open
yeah,
system
ISO is OSI,
model.
right? Yeah, fine.
Good. So if you search that can explain to you. Layer 7, it's the application layer. Layer 4, it's combined the IP and TCP or IP and UDP. I will create my load balancer. Load balancers can be public or private. If they are public, it's because you can have an IP assigned to it. That IP can be a reserved IP or it can be an ephemeral IP. We discussed reserved IPs. I don't think that I have one. Nope. So I'm going to go with the ephemeral. What else? Name of load balancer, the visibility type. Public load balancers, they are defined on the region. If you are using regional, yes. If the network that you are using, the subnet, it's a regional subnet, it will create one instance on different availability domains if they are present. If not, they will just use the default domain. If you are using a non-regional AD specific subnet, you're going to have to specify 2 subnets here, so it can create the redundancy. If you are using a private load balancer, if you make it AD specific, it will not be redundant. If you are using a regional subnet, it will be redundant. Can I use OCI load balancer to manage traffic in my DC? No, it needs to be within the VCN.
Thanks, Orlando. And someone asked for the better resolution. I think if they put it on the full screen mode, then
Okay,
they should be able to see that better resolution.
okay, thanks for that. I will remind that if someone complains again. Thank you. Then the shape of the load balancer, it will define if we are how much bandwidth it can handle. We offer flexible shapes where you can just slide and pick the amount of the bandwidth that you want. And you have the option to set the minimum and the maximum for that. Or you can go with dynamic shapes where you already set the amount and that's it. We have dynamic shapes here. We still have dynamic shapes because it's for retrocompatibility. So eventually we might get rid of it. So it's the TMR, it's the amount of data that it's be able to transfer and manage. So if you have an application that it's you have a big server behind the load balancer, this load balancer needs to match what you have as the backend. If you have an instance that it's using 2-3 gigabytes, you have to come here and you have to scale accordingly. If all that traffic is going to be, you have external traffic. So, and it can go up to 8 gigabits. It's how fast it can handle. Let's keep provisioning here, and maybe we're gonna save the questions to the end because they might have been answered here as I go. We're gonna define the VCN that it's going to be attached, the subnet. You can integrate with security groups, and you can have multiple security groups here. We will not, because if I want to keep things simple, I'm going to open on the security list for all the traffic. Advanced options, it's just tagging, the usual things that we do. If we're going to have the WAF, should make a deeper inspection, but we can leave that for when we talk about the WAF. Next thing you have to select is what's going to be how you're going to balance, what's going to be the policy, the algorithm that's going to be used. Weighted round robin, it will distribute according to the weight of each server. If you have one server that has weight 2, another one with weight 1, the one that has a greater weight will receive more connections than the other one. If they all have the same weight, they will be distributed evenly. when you're using IP hash, it's a combination that it creates a hash with the IP and with the persistency cookie to make sure that all the requests coming from one specific client keep going to the same backend server. That is important because, for example, if your application, let's say you have an e-commerce application and the cart for that application is kept individually on each server. If you do the first request to one server, you add stuff to the cart. If it happens that on another request, as you keep shopping, you go and reach another server, the cart will be empty on that one, and that will result in a poor experience. There are ways to work around that, but for the sake of our example, that's how we're going to consider here, that each application server has their separated sessions. So that helps you keep sticky connections with just one server. List connections is it averages the number of connections that each server is handling, and the one with less connections is the one that will get the new connection that will be. Here is where you add the backends. It will list the instances within the compartment, and you can pick from here. But as we are creating an auto-scaling configuration, we will not add anything here. We're going to leave the backend empty at the moment because they will be filled by our pool that we stopped. We paused the creation there. The health check session specifies how the load balancer will check that the backend servers are responding properly. So you can do that just querying the port and going to a specific path. Or, if you choose TCP, you just see if the port is open. Or if you want to do a health check that it's more elaborated, you can go with HTTP. And for example, you could have a health status page. And if that health status page is returning 200, that's fine. You can specify the path of the page. If that page is like, for example, a dynamic page that you have, you are doing some checks, or I'm making sure that the web server can connect to the database. You are speeding some text. You can query that text here as a parameter for the health check. If you want to enable SSL communication with the backend server, you just click here and you will enter the information for the certificate. We recently released the OCI certificates where you can manage the certificates. So if you imported the certificate that you are using with the web server, you can just come and select from here. In the past, you would have the certificates would be managed individually by product, and that was a hassle. Now it's much easier. You just import the certificates under the certificates. I'm just making a mention on it. It's not part of the exam, but it's important for you to know that the feature is there. Let's go to the listener. The listener will define how it will listen to requests, the protocol that it will use. In this case, we are going with HTTP because we don't want to set up the encryption. If you wanted to use secure HTTPS, you would click on this button here, HTTP version 2, or if you want to just forward the port like the network load balancer would do, you could mimic it here, but it works only with TCP. So making a comparison between network load balancer and the load balancer, it will do layer 4 TCP only. If you go with the network load balancer, it does all protocols that you might need. And again, this one is paid. The other one, it's for free. You have one or two instances that on the always free you can use if you are limited to 10 megabit, the micro instance. So going back to our thing here, we're going to use port 80 HTTP. I'm going to go forward. We didn't talk about logs, but here you can set up the logs and you can pick up the group where you want to. You can create a log group. We're going to go a bit more over that when we go on logging. And what's the name of the log here? By default, it's enabled for errors. If you want to have access as well, you just click here and it will show a similar screen for you. When we talk about logging, we can save this for later because we can do that from another screen. Let's create. It will take some minutes to provision. So in the meantime, load balancer can be adjusted based on data metric from where? Here on the metric, you can see the number of requests, the traffic that you have. If you want to adjust, you can click here and update shape, and you can make it bigger or smaller. This function could also be you could do that programmatically. You can create an alert. You can adjust it dynamic. It will go, you're going to have a slightly interruption when you're doing that. So you want to be mindful when you are going to do to change the shape. Do you have load balance options? Yes, I think that we showed that. Well, this we showed on the creation. After it creates, no, it's not routing policies. No. So on the creation, you set what's going to be the type of policy that you use. So the usual metrics that we have. We're not going to cover a smart check on this. We talked briefly about the logs. The backend set is, we have a backend set, but it's empty because we didn't create anything in it. We didn't add any servers. Routing policies. You can add conditions here that you can evaluate, for example, path, if you have certain cookies, if you have query, you guys can see. You can have path, you can have the request cookies, request header, and you can filter that. And depending on the action that you select, you can go to different backend sets. How can you use that? You could, for example, have a header that says that VIP customer and value equals true. And with that, if you have like two backend servers, backend sets, you can have one backend set with premium servers and you can have ordinary servers. And based on the header that you have here, if it's a VIP customer that it's paying you more, you can direct them to this premium server and offer faster responses, different features, and all that. So you can do that with the routing rules. And you can have several rules, and you have to understand how they're going to compare one to the other. If they match all the conditions, then the action will be taken here. Let's cancel. The rule sets. You can create set of rules here. where you can filter the based on IP. You can do some redirect rules. We're going to skip that for now. Let's go with the basic thing. The listener that we showed on the when we created the load balancer, it specifies what on the which ports on the public IP you're going to be using. One listener can cover different backend sets and different host names. So you don't have to, if you have multiple websites, they will go to the same listener and you will have to have different host names here. So the load balancer can understand that if you want to go to example.com, you have to send to one backend set. And if you go to test.com, should be to a different backend set. So you have to create the host name here, but they will be using the same listener. The listener just works on the network part of things, on the IP. The host name, it goes on the upper layer. It goes on the layer 7. It's where you put the host name that will be used for that request. Cipher suites is just if you have requirements that you want to specify a different one. The most common, and according to what we define as the security standards, they are here. Certificates, it's integrated with the certificate services. So if you are using HTTPS, HTTP2, you can get that certificate that you already imported through the certificates manager and just refer to them here. We talked about host names. And the path route sets is the same way that we have routing policies here that based on header, based on cookie, we will direct the requests to a different server. You can have that based on the path of the URL. So if we look at on the URL that we have here, our host name is cloud.oracle.com. All this part here, it's part of the path. What comes after the question mark, it's going to be the query part with some parameters that you're passing. So I can use the path route set to say, hey, if you have some name here that contains, instead of São Paulo, could be Ashburn, send to a different backend server, backend set, sorry. So you can route traffic based on that as well. So this is the beginning of the load balancer. If we need this, as we do the policy, if we need something, we can come back here and get more details. Any more questions on load balancer at this point? Just to see if we can go back on the auto scaling. Okay, so let's go back to our auto scaling. We paused on step 2. So we have the load balancer that we want to add. The load balancer is here. We have a backend set that we are going to use. We left it empty. The port of the load balancer is using port 80. If you have multiple load balancers, you can add them here as well. But in our example, we have just one. And we're going to next to review what we entered. And I missed something. Okay, oh, I forgot here. We talked about the subnet, but I didn't pick any subnet here. The review screen with all the information, and I will create my instance pool. As I mentioned, the instance pool is a group of instances that you control together. If it's associated with a load balancer, it's going to be shown here. If you have running instances, it will be here. Someone out of mute again. Sorry for that. And you can manually attach instances. So instead of relying just on what's created through there, you can just get an existing instance and attach, but I will do this here. Actually, I don't know if this instance is ready to be a web server. I'm going to remove it. And if you add it here, where is the, no, oh, number of instances, 1. I will detach this guy here. I'm going to leave just the other ones that we have. I don't want to work with this these options because I want my instance to remain there. Detaching pool. I'm going to create one instance. I want it to always have at least one instance. So I will save here. It will change it to scaling. And on the attached, as we removed one, it will create a new instance here in a minute. So as you guys can see, you can control the number of instances that you have manually here. But instead of doing something tedious like this, what you can do is you can create an auto scaling configuration. The same way as the pool, I can create the scaling from here, the auto scaling configuration from here, or I can create the auto scaling configuration from the previous screen for compute and then associate with the pool. Creating from here saves you some time. Is there any service limit quotas tied to number of instances? There's not a size for the pool. It's your tenancy limits that we will apply here. Auto scaling configuration, the name, the compartment, the usual good stuff. And the policy can be metric based, where you have triggers that measure the CPU utilization or memory utilization. And that's the criteria that it uses to increase the number of pool members or not, or to shrink. Or it can be based in one schedule. When are you going to use one or the other? You know, for example, that your users, let's get a scenario where you are a university and you have an application that your teachers use to make the presentations. As we're talking about in-person classes, though, you know when those classes happen, you have the schedule, you know that it's like from 8 in the morning to 6 in the afternoon, and you can predict when you want to have more servers so the teachers can use it throughout the day. You don't have to keep those resources up and running during the night because you don't have classes during that. So that will be one use for the scheduled base. You can set that. You're gonna have to set policies for the target. So you will create one to increase the pool at a certain time, and then you will add another policy to reduce the number based on the time that you select here. You can just come and say that it's gonna be We can call this increase. I'm going to have a target pool. I could say 4. And 8 is the first class. I want it to be ready before by 7:45. So you're just going to come on 7:45. Day of the month. You don't care about the day of the month. You don't care about the month. So all months, sorry. Day of the week. We know that we have classes just from Monday to Friday and all the years. This is similar to the cron tab that we have on Linux, kinda. They call it Quartz standard. You can fix this by adding this here. You don't have to memorize. Maybe on the exam, sometimes they give you without the name of the fields on top, but we're trying to change that because we don't want you to have to memorize this, but you have the idea, the minute, the hour, day of the month. It's important to understand that the question mark means you don't care. The star means all of the values, all the possible values within the month here. Day of the weeks can come on this format, or they can come from 0 to 6 as well. And the year is a 4-digit, or you can use a star. Yeah, that's it. We gave the example of the college in person, we know the hours and all that. But let's say that your college started to also offer online students. And with online students, you don't know when they're going to come to watch the lectures and do the labs and all that. So we are going to create a metric based, because depending on the number of students, that will create a higher load on the server, and that higher load is what's going to trigger to have more instances on the pool. The policy will send the command to the pool, say, hey, give me 1 more server, 2 more servers, and they do that. The instance pool configuration is fetching the information from the pool that we created, that we started this wizard. You're going to have the policy name. If you're going to use CPU or memory, what is going to be the scale out? So if the threshold performance goes beyond 80%, you add 1 instance. This threshold here is calculated on the average of all the servers. So in our test here, our pool already has 1 server. We just have to stress that 1 server, and that will trigger the creation of another one. If we want to go beyond and have, for example, to force it to have 3 servers, we would have to increase the load on all the existing servers that we have on the pool to go beyond 80%. This value here, you have to know your application to see how comfortable your users will be and how they're affected, so you can gauge when is the right threshold to initiate spinning a new server. Remember that it takes some time to the instance to be created. It's based on the average, so you have to account that it's not something that it's immediate. You have to make those considerations when you're going to select the threshold that you want to keep the experience good for your users. Scale in rule, when you're going to remove a server. So if the load falls below a certain threshold, the number of instances that you want to remove. Scaling, I'm going to say that limits, I'm going to always have 1. The pool starts with 1, and I'm going to go to a maximum of 3. If you make a mess here with these numbers, when you click on next, they will tell you and you can fix it. my values are okay. I don't have any problems. You review the information that you added, and let's create our our auto scaling policy. Let's inspect our instance pool. We have an instance here with a weird name, and if we check in the instance pool, is the one instance that we set here as the minimum number to start, the initial number the pool should have to start. The instance pool is using the load balancer, so when it creates the instance, it will attach it to the load balancer. So if I come here on the load balancer, no, sorry, it went to the wrong place. If I come to the load balancer, I have it open here. Let me just refresh it. And if you look at the backend set, backends, we have our server here. It's saying that the connection failed. So what we have to do here is a little bit of troubleshooting. Instances. I don't have a public IP here. So I'm going to have to use this server to connect. And from this server, I can connect here. What we're going to do later on is I'm going to show you how you can use the Bastion service to reach this guy. For now, as I already have this set up, let's take a look on the... I already copied my private key to this instance, so I don't have to... I think I did. Let me check the local firewall. Port 8 is open. System status. Apparently my cloud init has a problem because it didn't install Apache. Okay, we have a problem here with this guy. So let me just take a look if this instance is okay. HTTP. No, it's not installed as well. I know the problem is we didn't assign the public IP here, and it was not able to connect to this subnet. If you guys remember when we did the NAT gateway and the other and the internet gateway lab, it's using the route. I would have to have a different route for this guy here, but as the route is assigned on the subnet level, this will not work. Let me fix this in the my load balancer configuration. Nope, it will not allow. Let me fix this real quick. I will recreate everything in a minute. Delete. And guys, this is a bit important to see it working because we have questions on that. Terminate. Oh. Delete this, guys. Okay, you're terminating. I will create a template. So this is another way to create the instance, that the configuration. You can create the instance first, make sure that everything is working as it should. On the same subnet. I will assign an IP this time, although it's not needed, because the load balancer will is the one that's going to pass the request to this guy. Advanced options, my cloud init. So if you're installing packets and all that, you have to have a route to the net gateway so it can reach the EM servers and fetch the packets from there. Let's wait until it's provision. If I have problems here, we will skip the part of the web server, but I can still demonstrate how the pool scales under stress. We can still test the auto scaling policy. Let me redo this guy too, because I might have to do something wrong here. Public, the shapes, flexible shape, VCN1, pub1. I want it to be round robin, no backend sets. Next, HTTP. Error logs. Okay, everything set as it should. Submit here. Okay, this instance is up. Let me just check if it installed the it's still updating. Well, for some reason, it's not. My Cloud Init has a problem. As our goal is not to troubleshoot Cloud Init and its work on the auto scaling, create instance configuration. Demo config, create. Create an instance pool, demo pool. I will start with one instance. It's going to be here. Okay. Next. I'll create my pool here. It's provisioning because we created with one attached instance on the work request. It's in progress. Soon it will be provisioned here. Let's wait until it's provisioned. Okay, it's up and running. Oops, sorry. I will create my auto scaling. Add one instance. If it drops to 40. What I didn't fill here. Okay, CPU utilization. It's still finishing some process here on the instance that was just created. So we look here for our instance pool. Why it's not a demo pool. The instance that I'm connected here is this instance. So let's see if it finished. Because I need to install an extra package here. Sorry for that. I don't think I have a problem with the cloud init. I connected on the previous instance. It's just taking longer than usual to do the update. So that's the template that we used. Let's wait this guy come finish the update. Okay. So if I had been patient a little bit, that would have worked. Okay. I will attach the load balancer here. We can do that at any time. Load balancer will take some time to work. In the meantime, let's work on the pool. Sorry, I attached the load balancer here because we can attach that at any time. It's not a problem. Let's get this bad boy stressed. So for this, there's this stress utility. Stress dash n 10. So I created 10 threads of the stress. If when we look here on the metrics, they should be coming up. You can also see that if you go to the instance, this metrics here should update soon to reflect the load that we're pushing there on the server. So you can do from the instance level, or if you watch on the pool, we should be seeing here. This takes a couple minutes to what you can see, Andrew. I'm showing the demo pool here with the, okay, just a glitch. On my Linux box, I have just the stress running. I can send it to background. If I run top here, you're going to see that the control. So if you look at the load average here, it's far beyond the 2 threads that we have. This should make the things spike a little bit here. But again, it's calculated on the average. It takes a couple minutes. While we wait, we can take a look at the
Can you change the quick selects from last hour to something shorter duration?
The selection of what?
On the previous screen, there was a quick selects last hour. Is that like the last 5 minutes or something, or?
No, it's just to, this is here just to set the time here. It's just a shortcut. But see that the CPU utilization here, it's all the way up when it updated the graphic.
There it goes, okay.
It's not real time, it's close to that, but every now and then you have to give a couple nudges because everything that works over the web can have some hiccups. So the load is increasing here.
So that quick selects is more of a display, not a get faster updates.
Now the faster updates is if you have this.
Oh, there's
this
the
one here.
Okay, yeah,
the
I knew it was there somewhere. Thank you.
And this one here, it's just shortcuts to map a specific time interval that you want to check.
Okay.
If we go with last 7 days, it gets too tiny, but it can force a refresh as well. So if everything goes okay, I should be seeing this change. Let's go here, compute. No, I don't have any metrics inside here. But let's wait, just wait until this changes here. What I was going to show you guys is, today we should explore a little bit this observability and monitoring as well. If you go to observability and monitoring, here on the system metrics, you can decide what you want to check. For example, if you want to go with the compute agent, it can show you your instances here that are on the compartment in a single place. Same way that you will see inside the pool, here you can get from all the instances, not only the ones in the pool. If you go with Metrics Explorer, you can start filtering. Again, I will go with Compute Agent. CPU utilization. And I can filter based on, so you have the compartment where things are, the type of the metric that you want to search for, that you're going to use. The metric, the dimension is how you are going to filter. I'm going to filter based on resource display name. And I want to see, for example, just this instance. If I update the chart, that instance is there. If I want to get, for example, the whole pool, I should have created a different compartment for them, or I can use a different, I can go by the resource ID, and I could add another dimension here and get all the ones that I want to combine, and I can aggregate in a single graphic. Demo pool. And they are not helping me. So let's keep this running until it changes. Let me just review once more my auto scaling configuration. Cool down 10 minutes, start scaling policy. CPU utilization 80%. Yes, that's right. Okay, I was just impatient. It's scaling. So when we come to attached instances, soon we're going to see another instance coming here. Let's go back to the metrics that we were finished exploring. So you can see them combined here. From this screen as well, you can create alerts. Demo alert, the type of the alert that you want. If you want to mention something here on the message. And again, the metric that you're going to select. If we want to monitor CPU utilization, it's on the compute agent, but it could be other compute, because if you are accessing the metadata, file storage, if you reached a certain amount of storage that you are using, the load balancer could be the traffic that you have, the instance pool, the number of instances that you spin, it's a certain threshold, so you need someone to take a look why it's getting so big. You could create all these kind of things. If we go with CPU utilization, the interval, metric dynamics, dimensions, it's where you filter what is the resource that you want to have to be monitored. This is our first guy on the pool. No, so not the demo pool, this one. This is our instance. What's going to trigger if the value, we're going with CPU utilization beyond 80 over 1 minute, it's going to kick that for us. What kind of notification that we want? You have to create a topic, and this topic will define if it's a demo topic. I don't need a description for that. In this case, you can use email, you can call a function, you can go to a URL to report it, PagerDuty, Slack, send an SMS. So you can configure all that here. Let's go with email. Gmail.com. The type of message that you want. If you want to repeat the notification, that can generate a whole bunch of emails. You don't want that. If you don't check this box, just when the state of the alarm changes is that you're going to get something. If you are doing a maintenance and you are expecting it to happen, you can suppress notifications for that. I will enable.
Is this level of detail on the exam?
No. But as we were here, the destination, I have to create from outside. So let's go back to the code thing that we were doing. So that was just about the alarms. I can go back tomorrow when we have more time if you guys are interested in seeing there. Now we have two pools here. If we go on the IP address of the load balancer, let's see what would happen. No, load balancers, that's what I want. IP. Before we have any surprises, let me see if the load balancers are accessible from the internet. The easiest way is through my security list. I already have port 80 open. This should go. And I reach one of the servers. If I refresh here, I go to the other server because I'm using round robin. So every request that goes, it will balance. So if I keep refreshing this, it will go to different servers. If instead of round robin, I selected a different policy, I would stick with the same server. Or if I were using least connections, I would go to the server with less connections. And with that, for the sake of time, we will not go with I will not wait until it cools down, but let me show you. We can get back on that later. I will not wait. I have the stress process running here. I killed the process. The load should start to reduce. I don't see them listed here anymore.